Okay, question 7. We've got a book which has a mass of 0.8 kilograms, so its weight is 0.8 g newtons. It's acting on a rough plane. This angle here, the angle between the plane and the horizontal, is 60 degrees. The book is just prevented from sliding down the plane. Now that's important because it means that the frictional force that's acting must be the maximum possible frictional force. And it's about to slide down the plane, so the frictional force must act up the plane. And that frictional force is being helped by a 5 Newton force which is acting up the slope. We've also, as usual, got the normal reaction here. And if I just put in some angles, this angle here is going to be 30. If I put in, as usual, this line that's going in the opposite direction to R, this must be 60 degrees. Horizontally here then acting, I have got, there's an angle of 30, and this is my usual 60 degrees. And the question asks me to find the coefficient of friction. Well, first of all, I know that the forces acting away from the slope, and that's going to be R in this case, must equal the forces which are acting towards the slope, and that's the component of the weight acting in this direction. So that's just 0.8 g cos 60 degrees. Cos 60 degrees is actually just a half, so R is going to be 0.8 times g times a half, and half of 0.8 is 0.4, so R is just 0.4 g. My frictional force then is at a maximum, and we know that F max is equal to mu R. So I know that F max is going to be mu multiplied by this, so that's going to be 0.4 g mu. Now I also know that I've got my particle is in equilibrium, so the forces acting up the slope must equal the forces which are acting down the slope. Acting up the slope, I've got 5 plus F, and that F is F max, so 5 plus F max acting up the slope must equal the component of the weight which is acting down the slope, and that's 0.8 g cos 30 degrees. Now if I just substitute in here, I already know that F max is 0.4 g mu, and the right hand side is just still 0.8 g cos 30 degrees. So if I want to find mu, I'm going to subtract 5 from both sides, so that's 0.8 g cos 30 degrees. Take away 5, and if I then divide that by 0.4 g, obviously g is 9.8, I end up with mu is equal to the answer in the back of the book, which I've forgotten, comes out as 0.457. Mu comes out as 0.457 to 3 significant figures.